BYD, or Build Your Dreams, is a massive company from China which arrived in Europe with the BYD Atto 3.
In a world hurtling toward electrification, BYD, the Chinese automotive powerhouse, is changing the rules of the game in such a way that it can't be played the same way ever again. The company has risen to global prominence as the best-selling car brand in China and the undisputed leader in electric vehicle production worldwide. With over 4.3 million vehicles produced in 2024 alone, BYD is shaping the future of mobility. Now, the BYD CEO has claimed that their new engine will shake the entire EV industry. This is one update you can't afford to miss. The fifth-generation DM hybrid system. BYD has already made its mark in the EV industry, surpassing Tesla and claiming the #1 position, and now it is ready to dominate the hybrid vehicle market too. This is thanks to their fifth-generation DM, or dual-mode hybrid platform. At the heart of this system lies a meticulously engineered 1.5-litre gasoline engine, delivering 74 kilowatts, or approximately 99 horsepower, and 126 newton-meters of torque. Though these figures might seem modest when compared to traditional internal combustion engines, the magic of this powertrain is in its synergy. Paired with one of two high-efficiency electric motors, offering outputs of either 120 kilowatts or 160 kilowatts, this engine serves as a power generator and range extender rather than a standalone drive mechanism. The system is built on BYD's DMI fuel economy-focused and DMP performance-focused architectures, with the Qin L DMI and Seal U6 DMI serving as its flagship models. These vehicles not only embody BYD's hybrid engineering prowess, but also reflect a broader shift in consumer demand toward vehicles that offer both performance and sustainability without compromise. These are the passenger vehicles of the future, a future where automobile manufacturing will be monopolized by BYD, it seems. The new engine boasts an unprecedented thermal efficiency of 46.06%, a figure that firmly establishes it as the most thermally efficient mass-market internal combustion engine on the planet. To understand the weight of this achievement, it's worth noting that most conventional gasoline engines operate with thermal efficiencies ranging between 30 and 38%. Even Toyota, long considered the benchmark in hybrid technology, only recently approached the 40% mark with its latest Prius models. BYD's surpassing of the 46% threshold places it in a league of its own, reflecting years of focused R&D, component refinement, and system integration. The high thermal efficiency results in significantly less energy lost as heat, meaning more of the fuel's energy is effectively converted into usable power. Naturally, the total combined driving range is very impressive. With a full tank of gasoline and a fully charged battery, BYD's fifth-generation DM hybrid vehicles can travel an astonishing 200 kilometers, or roughly 1,104 miles, without requiring a refill or recharge. In comparison, the Toyota Prius can go on for 980 kilometers or 610 miles. This number isn't just impressive on paper, it addresses one of the most persistent limitations of electric vehicles: range anxiety. For consumers in countries with underdeveloped EV infrastructure, or for those who frequently travel long distances, this development offers unparalleled practicality. The range easily covers a round trip from Beijing to Shanghai, which is 2,500 kilometers, with only one stop to refuel or recharge. No existing fully electric vehicle can currently match this feat without extensive downtime for charging. The new hybrid models, the Qin LDMI and Seal O6 DMI, serve as technological showcases and market disruptors. The Qin LDMI is an elegant, family-oriented mid-size sedan, while the Seal 06 DMI targets younger, tech-savvy urban professionals with its sleek coupe-like profile and futuristic cockpit. Both models leverage BYD's new e-Platform 3.0, a modular architecture optimized for hybrid and electric drivetrains. This platform allows for smoother integration of components, contributing to the reduced weight, improved energy distribution, and enhanced safety standards these vehicles offer. Additionally, both cars come equipped with BYD's signature Blade battery, an ultra-safe lithium iron phosphate, or LFP battery, known for its long cycle life, structural integrity, and thermal stability. Charging and refueling logistics have also been streamlined. In urban driving, the electric motor takes the lead, silently and efficiently powering the vehicle. On highways or under high load, the petrol engine kicks in not only to provide power directly to the wheels when needed, in DMP mode, but also to recharge the battery, ensuring that the vehicle can continue to run in electric mode even in the absence of external charging infrastructure. The battery, which has a capacity ranging from 18 kilowatt-hours to 30 kilowatt-hours depending on the variant, supports fast charging as well, reaching 30 to 80% charge in under 30 minutes at compatible DC fast charging stations. With regenerative braking and intelligent energy management systems, BYD ensures that even urban stop-and-go traffic contributes to maintaining optimal battery levels. The strategic timing of this launch is simply perfect for BYD. China is already the world's largest auto market, and in 2023, BYD overtook Tesla as the world's leading EV producer, having delivered over 3 million battery electric vehicles and plug-in hybrids. The next year, BYD sold over 4 million vehicles worldwide. The new hybrid system, with its adaptable powertrain and extreme range, is especially appealing in markets like India, Brazil, and Australia, countries where full EV infrastructure is still a work in progress. Environmental impact has been central to BYD's branding and development philosophy. With global climate targets tightening and many nations phasing out pure combustion engines over the next decade, hybrid vehicles are seen as a crucial transitional technology. BYD's new DM system burns less fuel than traditional hybrids and emits significantly fewer pollutants. During internal testing, carbon dioxide emissions under real-world driving conditions were shown to be up to 50% lower than those of comparable gasoline-only models. The cost factor is another point where BYD is challenging the status quo. While most automakers struggle to deliver hybrid systems at a competitive price, BYD's vertical integration, from battery production to semiconductor design and vehicle assembly, allows it to keep costs down. Early estimates suggest that the Qin L DMI and Seal 06 DMI could be priced between $16,500 and $22,000, making them vastly more affordable than comparable offerings from Japanese, Korean, or Western manufacturers. For instance, the Toyota Prius, arguably the most iconic hybrid, starts at a considerably higher price point and offers significantly lower electric-only range and thermal efficiency. As the global transportation ecosystem prepares for its most significant transformation in over a century, BYD has emerged not just as a participant, but as a trailblazer. With the fifth-generation DM system, BYD is building the blueprint for the hybrid vehicles of the future. Long-range, low-emission, digitally integrated machines that don't ask consumers to compromise between performance and planet. So, what options is BYD offering? Versatile DM – variants for diverse drivers. With the launch of its fifth-generation DM hybrid system in 2024, BYD has not only redefined hybrid engine efficiency, but also broadened the appeal of hybrid vehicles by introducing a trio of highly specialized variants tailored to suit the diverse lifestyles and driving needs of its global customer base. These three distinctive hybrid modes, DMI, DMP, and the newly revealed DMO, form the cornerstone of a new strategy by BYD to dominate across three key market segments: daily commuting, high-performance motoring, and off-road exploration. This move underscores BYD's commitment to democratizing hybrid technology by offering adaptable powertrain solutions that are not only efficient, but also aligned with the nuances of real-world driving conditions and consumer behavior across geographies. The DMI variant, short for Dual Mode Intelligent, is optimized for fuel efficiency and electric-only driving. BYD introduced this configuration in late 2020 with the Qin Plus DMI, but the fifth-generation refinement brings a level of optimization previously unseen in hybrids. The DMI platform is engineered specifically with the urban and suburban commuter in mind, drivers who typically travel 50 to 100 kilometers per day and seek low fuel consumption, minimal emissions, and a quiet, seamless driving experience. In its 2024 form, the DMI is powered by a 1.5-litre naturally aspirated Atkinson cycle engine, delivering 99 horsepower, paired with an electric motor ranging from 161 to 215 horsepower, depending on the trim. Battery capacities range from 10.08 to 15.87 kilowatt-hour, enabling pure electric ranges of 80 to 120 kilometers or 50 to 75 miles, which is more than sufficient for most daily commutes. For context, according to data from China's Ministry of Transport, the average daily commute for urban Chinese workers is just 22.8 kilometers. What sets the DMI system apart is its focus on prioritizing electric drive under most conditions. The petrol engine primarily serves as a generator for the electric motor and only engages to assist under heavy load or depleted battery conditions. This architecture results in remarkably low fuel consumption. Figures as low as 3.8 liters per 100 kilometers have been achieved in real-world tests. For a mid-size sedan like the Chinel DMI or a compact crossover like the Song Plus DMI, this level of economy is not just impressive, it's revolutionary, especially when paired with ultra-low emissions and near-silent operation in EV mode. Additionally, the transition between EV and hybrid modes is nearly imperceptible thanks to advanced software control systems that anticipate driving behavior and adjust energy deployment accordingly. While DMI appeals to the pragmatist, the DMP, short for dual mode performance, is engineered for those who crave speed and dynamic driving without completely giving up environmental sensibilities. First introduced in 2022 with performance models like the BYD Tang DMP and Han DMP, this platform takes full advantage of the electric motor's instant torque, while combining it with a more assertive role for the combustion engine. The latest DMP models feature dual electric motors, one on each axle, enabling full-time all-wheel drive and delivering a combined system output that exceeds 430 horsepower in some configurations. Acceleration figures are sports car-like. The 2024 BYD Destroyer 07 DMP, for instance, can sprint from 0 to 100 km per hour in just 4.3 seconds, a figure that rivals entry-level Teslas and far outpaces traditional internal combustion engine vehicles in its class. In terms of battery technology, the DMP variants typically utilize higher capacity blade batteries, ranging from 18 to 30 kilowatt-hours, to support both extended electric-only range and robust power output. While the electric-only range remains in the 80 to 120 kilometer bracket, the emphasis is on delivering sustained performance and aggressive torque distribution, particularly in dynamic driving conditions or mountainous terrain. Importantly, the DMP models are equipped with larger brakes, adaptive suspension systems, and performance tires, all tuned to ensure the power on tap can be deployed safely and effectively. BYD also integrates sport-specific drive modes, including track, drift, and launch control, elevating the DMP from a mere hybrid to a legitimate performance platform. For young professionals or tech-forward drivers in markets like Europe or the UAE, where performance sedans and SUVs are gaining traction, the DMP fills a compelling niche, thrilling performance with long-term sustainability. The newest and perhaps most intriguing addition to BYD's hybrid lineup is the DMO, short for Dual Mode Off-Road, which debuted in mid-2024 in tandem with the BYD Leopard 5 SUV and is designed for the adventure-driven motorist. This system is engineered for rugged environments, rural landscapes, and high-altitude conditions where torque delivery, energy independence, and multi-terrain adaptability are paramount. In this architecture, both the combustion engine and electric motors are designed to contribute substantial torque at low RPMs, ensuring maximum traction on sand, snow, and steep inclines. The DMO platform makes full use of BYD's in-house developed electric all-wheel drive technology and torque vectoring, delivering a maximum combined torque of over 700 Newton-meters, which is ample for towing, climbing, and navigating challenging terrain. To support these demanding use cases, DMO vehicles use reinforced blade batteries with protective shielding capable of withstanding high-impact conditions, as well as sealed motors that can operate in flooded or muddy terrain without shorting out. Moreover, the system includes features such as hill descent control, low-speed crawling modes, and multi-terrain traction control. The hybrid nature of the DMO platform also provides a key strategic advantage in remote areas: the ability to generate and store electrical energy from fuel. In isolated environments where charging stations are scarce or non-existent, the vehicle can convert gasoline into stored battery energy, ensuring continued electric drive capability. This is a game-changer for markets like Australia's outback, South Africa's highlands, or Latin America's mountainous zones, where EV range anxiety is a legitimate barrier to adoption. What makes BYD's suite of DM variants truly revolutionary is the seamless integration across models, architectures, and geographies. Each of these hybrid systems shares a foundational platform that allows for manufacturing efficiency and faster deployment. BYD's vertical integration strategy ensures that all critical components, from the lithium iron phosphate cells in the blade battery to the electric motor controllers and even vehicle software, are developed and manufactured in-house. This not only ensures quality control, but drastically reduces production costs, allowing BYD to offer hybrid variants across multiple price points. From a global policy perspective, the diversity of BYD's hybrid options aligns closely with regulatory developments. Countries like India, Indonesia, Mexico, and Turkey, where full electric vehicle adoption has been slow due to infrastructure constraints, are incentivizing hybrids as a bridge technology. BYD has responded by expanding its manufacturing footprint beyond China. In January 2024, the company broke ground on a $620 million assembly plant in Rayong, Thailand, dedicated to hybrid and EV production, with further investments announced in Brazil and Hungary. Each of these facilities will be producing DM variants suited to local market needs: DMI for high-density cities, DMP for affluent urban buyers, and DMO for rural and adventure-based markets. This multivariant approach is also strategic from a market penetration standpoint. Instead of positioning hybrid technology as a monolithic solution, BYD's segmentation strategy recognizes the needs of different drivers. But how did BYD do it? How BYD achieved the breakthrough? This breakthrough results from a range of sophisticated engineering solutions, all designed to optimize the combustion process, reduce energy losses, and improve overall system efficiency. One of the most significant innovations is the use of a high compression ratio. Operating at an impressive 16:1 compression ratio, the BYD engine can extract more energy from the fuel, increasing both power output and thermal efficiency. This advanced compression ratio allows for better combustion, ensuring that more of the energy in the fuel is converted into usable power, rather than being wasted as heat. By reducing the amount of fuel needed for the same amount of energy output, the engine contributes directly to lowering fuel consumption and carbon dioxide emissions, a key factor in the fight against climate change. BYD has also incorporated a series of advanced combustion control technologies to further enhance the efficiency of the hybrid system. These improvements include optimized air ducts and intelligent combustion systems that ensure the precise mixing of fuel and air, as well as highly accurate combustion timing. By maintaining optimal conditions for the combustion process, energy losses are minimized and the engine can operate at its peak efficiency for longer. Another key component in the success of the fifth-generation DM hybrid system is the integration of smart lubrication and split cooling technologies. These systems are designed to manage engine temperatures more effectively, reducing friction and wear while maintaining the engine's optimal operating conditions. By carefully controlling the lubrication process and directing cooling to the areas of the engine that need it most, these technologies ensure that the engine remains in top condition throughout its life. This not only increases the longevity of the engine, but also helps to maintain high levels of performance and efficiency over time. In combination with the high compression ratio and advanced combustion control, the smart lubrication and split cooling systems contribute to the overall success of the DM hybrid system, in terms of both efficiency and reliability. Thanks to these groundbreaking innovations, the fifth-generation DM hybrid system delivers remarkably low fuel consumption rates while still providing impressive power output. Whether the vehicle is operating in fully electric mode or relying on the internal combustion engine, the fifth-generation DM system ensures that every drop of fuel is used as efficiently as possible. One of the key components of the fifth-generation DM hybrid platform is its electric hybrid system, or EHS, which has seen significant improvements in this new iteration. The efficiency of the EHS has been increased to an impressive 92%, which represents a 5% improvement over previous versions. The EHS is responsible for managing the transition between electric and hybrid driving modes, ensuring that the vehicle operates at maximum efficiency regardless of driving conditions. In addition to improved efficiency, the power density of the EHS has been increased by 70%, enabling BYD to create lighter and more compact systems without sacrificing power output. This increase in power density has several advantages, including a reduction in the overall weight of the vehicle, which improves handling and performance. A lighter system also allows for better energy management, as less power is required to move the vehicle, further enhancing fuel efficiency and driving range. The compact size of the EHS system also frees up valuable space in the vehicle's interior, contributing to improved cabin space and comfort for passengers. BYD's focus on real-world practicality is evident in the application of this advanced technology to family-sized vehicles like the Chin L DMi and Seal 06 DMi. These models, both of which are equipped with the new fifth-generation DM hybrid system, offer spacious interiors, cutting-edge features, and excellent performance. BYD has ensured that the vehicles remain practical and usable for everyday families, with ample room for passengers and luggage, as well as a range of modern technologies designed to enhance comfort and convenience. For example, both the Chin L DMi and Seal 06 DMi come equipped with large infotainment screens, advanced driver assistance systems, and high-quality interior materials, making them ideal for long drives and daily commuting alike. This focus on practical usability demonstrates that BYD is committed to making its advanced hybrid technology accessible to a wide range of consumers, without compromising on performance or comfort. Then there's BYD's signature battery apparatus. The Blade battery's key role. Introduced in 2020, the Blade battery has garnered widespread attention for its contributions to making electric vehicles lighter, safer, and more space-efficient, setting the stage for the future of sustainable transportation. One of the key areas where BYD's Blade battery differentiates itself is in its innovative design, which stands in stark contrast to traditional lithium-ion batteries that are commonly used in EVs today. Traditional lithium-ion batteries, while powerful and reliable, tend to be bulky and require significant space within the vehicle's structure. These batteries are made up of large, rectangular cells that must be packed together in complex, often heavy configurations, increasing the overall weight and volume of the vehicle. This design, while functional, presents challenges in terms of space efficiency, safety, and cost. The Blade battery, however, employs a flat, blade-like design that significantly reduces the space needed for battery installation and enhances the overall efficiency of the system. This compact arrangement enables more cells to fit into a smaller space, offering a higher energy density in a more compact package. As a result, vehicles equipped with the Blade battery can achieve a longer driving range without compromising on passenger or cargo space. This is especially crucial for EV manufacturers, as it allows them to deliver vehicles that are both practical and capable of competing with traditional gasoline-powered cars in terms of range. For instance, the BYD Han EV, one of the first vehicles to use the Blade battery, offers a range of up to 605 kilometers on a single charge, depending on the variant. The Blade battery's compact design also helps address one of the biggest challenges faced by EV manufacturers, the issue of weight. Batteries are typically the heaviest component of an electric vehicle, and this added weight can detract from the vehicle's performance. particularly in terms of acceleration, handling, and overall energy efficiency. The Blade battery's lighter design contributes to reducing the overall weight of the vehicle, allowing for better performance and efficiency. This weight reduction also has the added benefit of improving the vehicle's energy efficiency, as less energy is required to move a lighter vehicle. Furthermore, the Blade battery's design allows for easier integration into the vehicle's structure, enabling manufacturers to better balance the weight distribution and improve handling dynamics. This is a crucial advantage in making electric vehicles more appealing to consumers, as it helps deliver a more enjoyable and responsive driving experience. Another significant advantage of the Blade battery is its safety features, which set it apart from traditional lithium-ion batteries, which, if damaged or improperly charged, can be prone to overheating, leading to fires or other dangerous situations. The Blade battery is constructed with a robust, durable structure that is designed to withstand impact and reduce the likelihood of battery failure in the event of a collision. Additionally, the Blade battery has been rigorously tested for safety, including in extreme conditions such as high-speed crashes, overcharging, and high temperatures. BYD's Blade battery passed the nail penetration test, which involves driving a nail through the battery to simulate extreme conditions. It passed all tests without catching fire. In addition to its physical design, the Blade battery also integrates advanced thermal management systems that help maintain optimal operating temperatures, further reducing the risk of overheating. The improved safety features of the Blade battery have been one of the key selling points for BYD, as safety concerns remain one of the most significant barriers to widespread EV adoption. By addressing these concerns with a more robust and reliable battery design, BYD has helped set new standards in terms of EV safety, contributing to greater consumer confidence in electric vehicles. The Blade battery also excels in terms of its energy efficiency and sustainability. The Blade battery uses BYD's proprietary lithium iron phosphate, or LFP chemistry, which is known for its high thermal stability and long cycle life. LFP batteries have a much lower environmental impact compared to other types of lithium-ion batteries, such as nickel, cobalt, manganese, or NCM batteries, which require the mining of rare and often environmentally damaging materials. LFP batteries, by contrast, use more abundant and sustainable raw materials, such as iron and phosphate, which are less harmful to the environment and less prone to supply chain volatility. This makes the Blade battery a more sustainable option for electric vehicles, aligning with the global push towards reducing the environmental impact of transportation. The Blade battery's long cycle life is another critical factor in its energy efficiency. Traditional lithium-ion batteries can degrade over time, losing their capacity to hold a charge and requiring replacement after several years of use. The Blade battery, on the other hand, is designed to offer a much longer lifespan, with BYD claiming that the battery can last up to 1.2 million kilometers or 750,000 miles in its lifetime. This extended lifespan reduces the need for frequent battery replacements, contributing to a lower total cost of ownership for consumers and a more sustainable solution for the environment. Additionally, the Blade battery's ability to retain its capacity over a longer period of time means that EV owners will benefit from more consistent performance throughout the life of the vehicle, further enhancing the appeal of electric vehicles as an alternative to traditional gasoline-powered cars. The Blade battery also plays a crucial role in making electric vehicles more space-efficient. As the demand for EVs continues to grow, manufacturers are looking for ways to maximize the use of space within their vehicles to accommodate more passengers, cargo, and advanced features. The Blade battery's slim, flat design allows it to be integrated into the floor of the vehicle, freeing up more space for other components and ensuring that passengers and cargo are not compromised by the need to accommodate bulky battery packs. This design also helps lower the vehicle's center of gravity, improving stability and handling. By optimizing the use of space in this way, the Blade battery enables EV manufacturers to create more spacious and comfortable interiors without sacrificing battery performance or range. One of the most promising applications of the Blade battery is its ability to power a wide range of vehicles, from compact sedans to large SUVs and buses. BYD has already begun integrating the Blade battery into its lineup of vehicles, including the BYD Tang SUV, the BYD Chin, and the BYD E6 electric MPV, with plans to expand its use to even more models in the future. As the demand for electric vehicles continues to rise, the Blade battery will play an essential role in shaping the future of transportation, helping to drive the global shift towards a cleaner, more sustainable future. With its continued development and integration into BYD's lineup of vehicles, the Blade battery is poised to become a cornerstone of the EV revolution. But wait, there's still more to this new DM engine system. Other components powering BYD's 5th generation DM engine. BYD's Xuanji architecture serves as the intelligent brain behind its electric vehicles, integrating and centralizing all core systems for a seamless, adaptive, and highly responsive driving experience. Replacing the outdated network of isolated electronic control units, or ECUs, Xuanji uses real-time data processing, machine learning, and sensor fusion to anticipate and respond to changing road, weather, and traffic conditions with exceptional speed and accuracy. With dynamic sensor prioritization, over-the-air software updates, robust redundancy mechanisms, and the ability to learn from individual driving habits, Xuanji delivers unparalleled safety, performance, and personalization. Then there's DeepSeek AI, which functions as a collective intelligence system embedded within BYD's electric vehicle fleet, transforming each car into a learning node within a vast network. Working in tandem with BYD's Xuanji architecture, DeepSeek AI continuously collects and analyzes real-time and historical data from individual vehicles and the entire fleet to optimize performance, predict maintenance needs, and enhance safety. It monitors everything from battery and motor health to driving conditions and user behavior, using this information to anticipate issues before they arise and suggest improvements in energy efficiency and driving strategies. Through its networked structure, if one vehicle encounters a problem or anomaly, others can be alerted to watch for similar patterns. DeepSeek AI also simulates various driving scenarios to fine-tune its algorithms further and can autonomously take preventive actions if imminent hazards are detected. This adaptive, proactive, and collaborative system not only extends vehicle lifespan and reduces costs, but also sets a new benchmark for intelligent, connected EV technology. Moreover, on February the 10th, 2025, BYD revolutionized the automotive world with the unveiling of DiPilot, a cutting-edge intelligent driving assistant that marks a major leap toward fully autonomous vehicles. Far beyond a simple update, DiPilot integrates advanced neural networks, machine learning, and multi-sensor technology to deliver human-like decision-making, rapid reflexes, and context-aware navigation in real time. Available in 3 tiers: DiPilot 600 for luxury models, DiPilot 300 for mid-range vehicles, and DiPilot 100 for budget options. The system ensures widespread access to smart driving features. Key innovations include high-speed navigation on autopilot for long-distance, hands-free travel, automated valet parking with near-perfect accuracy, and memory navigation that adapts to users' routines. All put together, these systems make BYD vehicles simply unbeatable. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.